Suppose you ordered a pizza that is cut into 6 equal slices. If you eat one slice and then eat another one later, how much of the pizza did you eat? Well, 1/6 is the unit of slices, and it's called a unit fraction because it's showing the unit of slices. So think of it like this, right? We have one whole pizza cut into 6 equal slices, and so each one of these slices is 1/6 of the whole pizza, where each one is 1/6, but total it's 2/6. That's what addition we'll find there. Now, if we have 6/6, which is the whole pizza, and we take off those 2/6 that we've eaten, then we're going to have 4/6. 1, 2, 3, 4. 4 out of the 6 remaining. That's 4/6 left. Of course, 2/6 can be reduced. We can divide top and bottom by 2. And we get 1/3 of the whole pizza is eaten. And 4/6, once again, divide top and bottom by 2. And we get 2/3 of the pizza remains. This is what was eaten. This is what remains. Okay, we can use this process for any kind of addition. You can see that really what we're doing here is we're just counting up these unit fractions in this case, but really we're just counting up the individual slices. Here we're going to have 5/12 and 2/12. Well, if we have 5/12, I think like a pizza that's cut into 12ths. If 5/12 were eaten and then 2 more were eaten, that means in total 5/12 plus 2/12 equals 7/12. Just like 3/8 and 7/8 more is going to be 10/8 total. Really what we're doing here, same thing for this one, is we're just adding the numerators together. 4 plus 2 is 6, and we're leaving it out of the denominator. Of course, you can also reduce, right? You can divide this by 2. That gives me 5/4, and we can divide this one by 3 on top and bottom to get 2/3. Subtraction works very much the same way. If we have 5/8 of a pizza and then 1 has been removed, then we have left 4/8, or reducing that, dividing top and bottom by 2, I'm going to get, I can divide top and bottom by 4 to get 1/2. If I have 11/12 and I remove 7/12 from that, 11/12 minus 7/12 is going to give us 4/12. Divide top and bottom by 4, and we're going to get 1/3. And finally, 12/13 minus 6/13 is going to be 6/13. 12 minus 6 is 6. In all these cases that I've shown here, the denominators were always the same, and that's not always the case. If the denominators are not the same, we have to actually reportion, quote unquote, reportion the denominators until they are the same, and then we can actually do the operation. So let's see that in practice here. So suppose you had 2 sheets of brownies. One is chocolate and one's butterscotch. The chocolate ones are cut into 12s. That's what we can see here. Is we have 12 slices here. And then the butterscotch ones are cut into 6 portions. We have 6 slices here. And if you were to eat one slice of each type, so one of the chocolate and one of the butterscotch, then this is what you'd have, right? But 1/12 plus 1/6, that's what we're looking at. Would you add it up to this one, right? 1 plus 1 is 2, 12 plus 6 is 18. Well, no, because in the previous cases, right, when we added the fractions together, we never touched the numerator or the denominator. The numerator was the only thing that we changed. That's because the denominator was what we were talking about. That's what the unit or the whole that we were talking about is related to. And then we're combining the numerators to add up to the correct portions. So the denominator needs to be the same. And that's what happens when we reportion the butterscotch brownies. If we cut each one of these into half, right, I'm just going to cut them all into half here. And I'm reportioning this whole thing into having 12 slices, just like the chocolate has 12 slices. Then I can cut this in half, right? I actually have 1 slice here and then 2 equal portioned slices. So in total we have 1, 2, 3, 3 out of the 12 slices. That's what makes up a whole pan of brownies. So this reportioning is changing the denominator to where they are the same, right? 1/12 became 1/12 plus 1/6 became 1/12 plus 2/12, which made us 3/12 as a fraction. Of course, that can be simplified down to 1/4. So we must have common denominators when we're doing these additions here, and then we're going to reduce the answer if possible. So we have 1/2 plus 2/3. The way we can get common denominators is we can build the fraction up into an equivalent fraction to where both 2 and 3 have the same multiple. So we want to have a common multiple in the denominator. So between 2 and 3, right? 2 and 3, 2 times 3 is 6. 2 can go into 6 and 3 can go into 6. So if I take 1/2 and I multiply it by 3 over 3, that's going to be 3 over 6. So 1/2 is the same thing as 3/6. And then 2/3 multiplied by 2 over 2 now, because 3 times 2 is 6, I get 4/6. So now I have 1/2 is the same thing as 3/6. 2/3 is the same thing as 4/6. 3/6 plus 4/6 is 7 over 6. And that's my answer. It can't be reduced. I can write it as a mixed number, right? 6 can go into 7 one time with 1 remaining. So this is my solution. That's the idea here. Now 3/8 and 5/6, 8 and 6 can both go into 8 times 6, which would be 48. So if I do 3 over 8 times 6 over 6 plus 5 over 6 times 8 over 8, you can see how in the denominators I have both 6 times 8. 8 times 6 is the same thing as 6 times 8. So what I get now is 18 over, I believe that's 48 plus 40 over 48. I haven't changed anything. I've just made the denominators a little bit easier to work with. 18 plus 40 is 58 over 48. And I can reduce top and bottom by 2, giving me 29 over 24, which is 1 and 5/24. That's my solution there. For the last one, we have 4/5 plus 3/8. 8 times 5 is 40. So I can get times by 8, times by 5. That's going to give me, 32 over 40 plus 15 over 40, which gives me 3, 8, and 10 is 47 over 40, which is going to be 1 and 7/40 for that one. Subtraction works very much the same way. We want to get common denominators and then move from there. So I'm going to get, right, 3 and 2 makes 6. So 3 times 2, 3 times 2, 2 times 3, 2 times 3. That's going to give me 4 over 6 minus 3 over 6 is 1 over 6. That's reduced. Okay, here I have 4 times 5. I'm going to multiply this by top and bottom by 5. Again, 4 times 5 and then 5 times 4. That's going to give me 15 over 20. It's the same thing as 3/4. I'm just making the same thing here. And then minus times by 4 on top and bottom. 2 times 4 is 8. 5 times 4 is 20. Common denominator, 15 minus 8 is 7 over 20. Okay, and then we have 4/5 minus 11/15. So I can multiply this one by 15 and multiply this one by 3. Okay, we get 4 times 15 is 60. 5 times 15, it's going to be 5 times 10 is 50. 5 times 5 is 25, so 75. 3 times 11 is 33 over 75. And now I can combine these two numerators. 60 minus 33. It's going to be 27 over 75. And both of these can be divided by 3. That's going to give me 9 over 25. That is what I get when I do subtraction of uncommon denominators. Now, we always have to have a common denominator for addition and subtraction. What's nice, though, to have is the least common denominator. The least common denominator makes the numbers the smallest when you're building them up, and it will end up being a lot easier to work with because the numbers are just smaller. They're easier to work with when they're smaller. So if we're going to add 1/2 and 1/8, we can use the denominator of 16 because 16 is 2 times 8. That's what I was showing you before. I'm going to multiply top and bottom by 8 here and multiply top and bottom by 2 here. I get 8 over 16 plus 2 over 16 give us 10 over 16, which can reduce, divided by 2, to get 5/8. That's the standard thing that I was just showing you. Now, we can also look at this thing and say, well, 2 can actually be transformed into 8 by doing 2 times 4. So 8 is actually also a common denominator, right? All I have to do is multiply this one by 4. That gives me 1 times 4 is 4, 2 times 4 is 8. So 4 over 8 plus this 1 over 8 now gives me 5 over 8. You can see I get the exact same answer, but I didn't have to do any reducing, and the numbers were smaller in the whole process. You can actually find the least common denominator, the LCD, by just looking at multiples of the denominator. So 2 and 8, right? 2, we have 2, 4, 6, 8, you know, all the multiples of 2. 8 is 8, 16, 24. You can see that we have 8, 16, 24 in there. And of course, the least one is going to be 8. That's the LCD between 2 and 8. Always use the least common denominator if you can see it. It's going to make the numbers easier to work with, like I said, because they're smaller. But if you can't see it, you can always just multiply 2 times 8 and 8 times 2. You can always do that process. But it's just kind of up to whether or not you can see that in the problem that you're working on. Okay, let's add and subtract. These are all mixed numbers. We need to get common denominators between the fractions. 5 and 3, the least common denominator between these two things is just going to be 5 times 3. That's because both 5 and 3 are prime numbers. So if you're going to look at the multiples of 3 and 5, you're going to find that it's just going to be 15, which is 3 times 5. So I'm going to multiply this one by 3 over 3, just the fraction, and this one by 5 over 5. That's going to give me 1 and 3/15 plus 2 and 10/15. And to add these mixed numbers together, we can add the whole parts, which is 1 and 2. That makes 3. And 3 and 10 give us 13/15. So this one's very easy to do with mixed numbers because this fraction didn't end up being an improper fraction. So if it does become an improper fraction, however, we have to do a different step to this. I believe that's what we're going to see here. The least common denominator between 2 and 8 is 8. So I'm just going to multiply this one by 4 over 4. That's going to give me 6 and 4/8 plus 3 and 5/8. Add the whole parts, 9. Add the numerators, 4 and 5 makes 9 over 8. This is an improper fraction, and a mixed number never has an improper fraction next to it. So I need to change this to a mixed number. Mixed numbers mean 9 and 9/8 is the same thing as 9 plus 9/8. That's what a mixed number notation means. 9/8 can be rewritten, though, as 1 and 1/8. And then we can add these two together to get 10 and 1/8. So you always have to keep in mind, do we have to rewrite this fraction as a new mixed number if it's improper? If you change these both into improper fractions first and then do the process, you don't have to do that. Worry about that step. We can see that here. If I just change this problem into 2 times 6 is 12, plus 1 is 13, 13 halves. 8 times 3 is 24, plus 5 is 29 eighths. I'm going to get common denominators. It's going to give me 2652 over 8, plus 29 over 8. 52 plus 29 is going to be 70 and 11, so 81 over 8. And then 8 can go into 81 10 times evenly with a 1 remainder. 10 and 1/8. We got the exact same answer. This does result in bigger numbers in the numerators because of how improper fractions work. But I find it be easier to work with improper fractions and only changing to mixed numbers if it's required as a interpretation. But if this makes more sense to you, then go ahead and do that. Okay, for this one, typically subtraction is better to do improper fractions because there's extra steps you have to worry about when you're looking at mixed numbers. I'll show you that here with this one. Common denominator here is going to be 30. 5 times 6. 6 times 5. Go ahead and list out the multiples of 5 and 6, and you're going to see that 30 is the first one. That's going to be the least common denominator. We're going to have 18 over 30 minus 1 and 25 over 30. And so this is the issue when you leave with mixed numbers, right? We're going to have 4 minus 1 is 3, and 18 minus 25. Well, we can't take 25 out of 18. So we can actually do this process is if we actually take 1 out of the 4, we're going to take a 3 here, and the denominator is 30. So for each 1 that we take out of here, we're going to add the denominator to the numerator. So we're going to take 30 plus 18 is actually going to be 48 thirtieths minus 1 and 25 thirtieths. And now we can actually do the process. 3 minus 1 is 2. 48 minus 25 is going to be 23. And that is my solution. If instead we were to do the improper fractions, right? 5 times 4 is 20, plus 3 is 23. And then 6 times 1 is 6, plus 5 is 11. Okay, now I need to get common denominators. All right, that's going to give me, I'm just going to do it down here. 23 times 6 is going to be 120 plus 18, so 138. Over 30 minus 55 over 30. 138 minus 55. 130 minus 50 is 80. And 8 minus 5 is 3. So 83 is what I should be getting there. That makes sense. And 30 can go into 83 2 times evenly with 23 out of 30 remaining. The exact same answer that I got the other way. Again, whichever way makes more sense to you, do it that way. I'm going to write it as an improper fraction here. 3 times 4 is 7. Or sorry, 3 times 4 is 12, plus 1 is 13. 3 plus 4 is 7. 4 times 1 is 4, plus 3 is 7. 12 is going to be the least common denominator because 3 times 4 is 12. Times by 3, times by 3. So it'll give me 2652 over 12 minus 21 over 12. Okay, subtracting that, it's going to give me 31. And then writing this as a mixed number. 12 can go to 31 2 times evenly. It's going to be 24. 31 minus 24 is 7 over 12. Okay, and those are the answers there. Okay, there are some special cases that can be confusing without just seeing them. That's whenever you have a whole number, what you want to do is change the whole number to a fraction. 5 is the same thing as 5 divided by 1. You can always divide a whole number by 1 to get a fraction. 5 divided by 1 is just 5. Now we can get common denominators here by multiplying this one by 2, right? 2 will be the least common denominator between 1 and 2. That's going to give me 10 over 2 minus 1/2. 10 divided by 2 is still 5. I haven't changed anything there. But now I can do 10 minus 1 is 9/2, which is the same thing as 4 1/2. So whenever you see a whole number, just divide it by 1, and that gives you a fraction that you can work with. Okay, 5 times 3 is 15, so 15 is the least common denominator. I'm going to multiply that one by 3 over 3. Give me 9 over 15 minus 9 over 15, which of course gives you 9 minus 9 is 0 over 15. 0 divided by any number that's not 0 is just 0. So when they're the same fraction, they're subtracting them, you get just 0, right? 1 minus 1 is 0. 18 minus 18 is 0. 3/5 minus 9/15, it's the same fraction. It just gives you 0. Okay, common denominator here is going to be 8. I'm going to multiply this one by 2 over 2. We get 2 over 8 plus 6 over 8. 2 and 6 gives us 8 over 8. And 8 can go into 8 one time. So this is just the whole number 1. You can also divide top and bottom by 8, right? And you're going to get 1 over 1, which is just 1 still. Okay, here, let's get common denominator of 6. 2 and 2, 6, plus 3 and 4, 6. 2 plus 3 is 5. 2 plus 4 is 6 over 6. This, 6 over 6, right, is just 1. So we get just a whole number there of 6. So once again, if the two fractions meet with this 6 over 6, you're going to add that to the whole part and give you positive 6 as your answer there. Okay, the next one. Once again, 6 is the common denominator. We're going to get 4 and 4/6 minus 3 and 4/6. 4 minus 3 is 1. And 4/6 minus 4/6, well, that's going to be 0/6, which is, again, just 0. So we just get 0 for the fractional part. So 1 is the answer there. The fraction actually is removed because it's 0 out of 6. No need to write it. Okay, and finally, right, we have a common denominator of 40, but 2 can go into 20. 2 times 10 is 20. So 2 times 10, we're going to get 50 over 20 plus 10 over 20, which gives us 60 over 20. You can, of course, reduce this if you want, keep reducing it down, or you can just see that 20 can go into 60 3 times evenly. So we get just, again, a whole number as our answer. No more fraction is necessary. And PEMDAS still applies even to fractions, so always work through that. The things that we haven't talked about yet is multiplication and division of fractions. So here you can see that all we have is parentheses and then addition and subtraction. We're going to get to that next, but here, just worry about addition and subtraction. Always work left to right. And again, you need to have common denominators between everything to add and subtract any fractions. So here, 8 and 4. Common denominator is 2. I'm going to add these two up. We're going 5 over 8 plus 6 over 8. 5 plus 6 is 11 over 8. I'm not going to worry about changing it to a mixed number. I'm going to complete the rest of the problem. And I have 40 is going to be my least common denominator here, 5 times 8. I get 55 minus 32, and that's going to give me 23 over 40 as my solution. So no need to change to a mixed number. We didn't need a mixed number in the end anyway, so we can just save some time by leaving them as improper fractions. Okay, 3 again, 3 over 1. That's what we want to do whenever we have a whole number. And we need to have common denominators here because we have to do parenthesis groups first. Multiply by 4 over 4. That's going to give me 12 over 4. 12 over 4 is the same thing as 3 minus 1 over 4. And here I can multiply 3 by 5 to get 15, giving me 5 over 15 plus 1 over 15. Okay, I have to do each parenthesis group first, so I'm just going to go ahead and do them at the same time before I can do the subtraction. 12 minus 1 is 11 over 4. 15 plus 1, or sorry, 5 plus 1 is 6 over 15. I need to get common denominators, so I must multiply this one by 15 and this one by the other one by 4. You can just, of course, list them out. The prime factorization of 4 is 2 times 2. The prime factorization of 15 is 3 times 5. There are no common factors. So that means I know the only way I can get a common denominator is by multiplying by the other denominator. When they have common factors like 8 and 4, the common factor is 4 here, that's when you can actually just multiply this number by something. You potentially have to multiply this number by something as well. It just depends on the fractions. But in general, if you're ever confused about what gives you a common denominator, just multiply by the other denominator, and that will give you common denominators. Okay, 15 times 11 is going to be 150 and 15, 165. And then 4 times 15 is 60, so we're going to minus 6 times 4 is 24 over 60. So doing that subtraction is going to give me 141 over 60. And of course, 60 can go to 140 twice. That's going to be 120, giving us 21 over 60. Either one of these is a valid solution.